Have you ever wondered how a CPU actually works? We're all taught one thing. CPUs are made of transistors. But what does that really mean? How do billions of tiny transistors carry data, make decisions, and turn instructions into everything you see on your screen? I know there are a lot of tech-curious minds who've wondered about this, so let's break it down step by step. So, let's start with the basics, the transistor. A transistor has 3 pins: the collector, the emitter, and the base. The collector is where power comes in. The emitter is where power goes out. But here's the interesting part. Power only flows from the collector to the emitter if a small signal is applied to the base. No signal at the base, no power flows to the emitter. And since power flows from the collector to the emitter, if there's no power at the collector, it doesn't matter whether the base is powered or not. The emitter outputs nothing. This tiny control is what makes a transistor a switch. Now, we all know CPUs work in binary. Unlike decimal numbers, which use digits from 0 to 9, binary uses just 2, 0 and 1. In a CPU, 0 means off and 1 means on. These zeros and ones are called bits. But a single bit isn't very useful, so bits are grouped together. Let's see how decimal numbers are represented in binary. And so on. For example, 8 bits form 1 byte, and an 8-bit number can represent values from 0 to 255. More bits mean larger numbers, and more data processed at once. So when we say a CPU is 32-bit, it processes data in 32-bit chunks. That's how CPUs handle numbers, data, and instructions. But how do transistors actually process these binary instructions and data? Well, a single transistor isn't enough to do any real processing. That's where logic comes in. Transistors are wired together in specific ways to form logic gates. A logic gate is a tiny circuit made of transistors that takes binary inputs and produces a binary output. For example, the AND gate. It has 2 inputs and 1 output. It outputs 1 only when both inputs are 1. These logic gates don't work alone. They're wired together in different combinations to form small functional chips. For example, the ALU, the arithmetic logic unit. It's not a single gate. It's a collection of many logic circuits working together to perform calculations. In this series, we'll build a simple CPU from scratch, just enough to understand the real thing.